Hey everyone, so in this video we're going to explore or look at elementary operations on matrices. So what you're going to see here is three kinds of basic operations can be performed on matrices, and these operations are performed either on the rows or on the columns of matrices. And what these operations allow us to do is transform a matrix from one form to another. And the reason we use these elementary operations is, for example, to compute the inverse of a matrix, or to take a matrix in a certain form like a complete filled up square matrix and convert it into an upper triangular or a lower triangular matrix and so on. So a lot of advanced use cases are there for these kind of operations. At this level you'll mainly use it to compute the inverse of a matrix. So let's delve straight into this. So the first kind of operation, elementary operation that can be performed, is interchanging the rows of the matrix. So take a square matrix, and this is for square matrices. So take a square matrix and take row I and row j. Now what you can do is switch those rows. So your row I now becomes row j and row j becomes row I. What do I mean by that? So let's show you an example and it will become very clear. You take this matrix here, it's a 3 by 3 matrix. So you have row 1 which is 2 3 1 and row 2 is 3 1 7. Now applying the switch operator here to row 1 and row 2, what you get is this. So what you see here is now row 1 has become 3 1 7 and row 2 has become 2 3 1. So by applying this operation, the rows have been switched. The first row has become the second and the second row has become the first, right, of the same matrix. So now the properties of the matrix have changed by applying this operation, and you will see in more advanced cases like the inverse where you actually use these kind of operations. Generally they are applied when there are two matrices on either side of an equal to sign. So you have a left hand side and a right hand side, like when you solve an algebraic equation, and these operations are applied to both sides of the matrices at the same time. That's how it's generally done, right? So for example, if you look at the video on the inverse using elementary operations, you should be able to understand that. But in this case, we've taken the first row and by applying this operation switched it with the second row. So now you can also do this for the columns, right? And so what you can do is take column I of the matrix and switch it with column j. So that's the column switch or column interchange operation. So same matrix here, but now we're going to take the first two columns, so 2 3 1 and 3 1 7, and we're going to apply the interchange operation, right? So c1 interchange c2, and what you get is now the first column has become 3 1 7 and the second column has become 2 3 1. So that's it. That's the first operation. You can switch a row or switch a column with another in the same matrix. Okay, so the second operation is multiplying a row by a scalar. So what you can do is take a row in the matrix, row I, and you can multiply that row with any non-zero scalar k, and that is denoted by this set of symbols where you have row I becomes a scalar k times row I. So let's look at an example. You have the same 2 3 1 matrix and you apply this operation to the first row. So we take the first row 2 3 1 and we apply the multiplying a row by a scalar operation. So we take row 1 and row 1 now becomes 2 times row 1. So you take row 1 and you multiply each element by 2, and what you get is the updated matrix where now row 1 is 4 6 2 instead of 2 3 1. So I think this step should be very clear, and as you can imagine, you can do this for every column as well. So you can take a column I from the matrix and you can multiply it by a scalar that's non-zero called k, and that becomes multiplying a column by a scalar elementary operation. So same matrix again, but now I'm going to take the first column and I'm going to apply the operation where now the first column becomes 2 times the first column. So take every element in that column, multiply it by 2, and what you end up with is 4 6 2 as the first column instead of 2 3 1. Now as you can see, the other columns are unchanged, right? It's just the first column has now undergone a change or a transformation. So that is the second elementary operation where you can take either a row or a column and multiply that by a scalar. Okay. Third is where what you can do is take a row and add to that some other row of the matrix multiplied by a scalar, right? So what do I mean by that? Well, it's denoted as this: row I now after the operation becomes row I itself plus some other row j multiplied by a scalar k, right? So this will look very clear when you look at the example, same example here, right? And I'm applying that operation where the scalar I'm using is 2, and so now row I becomes row 1 becomes row 1 plus 2 times row 2. So this is row 1, this is row 2, and so as you can see, row 1 now becomes the row 1 itself, which is these 3 numbers, plus 2 times row 2, which is this, right? Very simple. And the same can be done for column. So column I is column I plus k times column j, and actually it's very easy to visualize the case for the columns, because now you have these columns. So let's do the same thing. Say the first column, and you want the first column now to be the first column itself plus 2 times the second column. So 2 plus 2 times 3, 3 plus 2 times 1, 1 plus 2 times 7. You can see it's the first column, it's the second column. That's why I said it's easy to visualize this case for the second column, for columns. And what you get is, and as you can see, the second column is unchanged. The first column has become something else. Now instead of a plus, you can use a minus, right? Because if a scalar is negative, it effectively becomes minus. So you can do the same with a negative sign as well. So let's just refresh the 3 operations. The first is where you can switch a row with another or a column with another. The second is where you can take a row and multiply it by a scalar, or you can take a column and now multiply it by a scalar. And the third is where you can take a row and add to it a scalar times another row, or you can take a column and add to that column a scalar times another column. These are the 3 elementary operations. It's very simple. And once you learn these 3, just understand these 3, and as you can see, they're very, very simple. You can use these to perform fairly complicated operations on matrices, solve fairly complicated problems, of matrices. Okay, so let's look at an example. We start with the same set of numbers again, but now I'm going to apply the operations to something else. So take R2, which is this, is 3 times R2. So I first applied the scale, multiply by a scalar operator. So take this 317, and I'm multiplying that by 3. So now this row has become 9, 3, 21. So now I'm going to take this matrix, right, and I'm going to apply an operation to that. So which operation am I applying? I'm going to switch the columns. I'm going to switch column 1 with column 3. So switching the columns, you get 1, 21, 5, 2, 9, 1. So we have applied the switching operation to this, right? And as you can see, already we started with a completely different matrix, and with 2 sets of operations we are ending up with something completely different, right? Okay. And now the third is we're going to take that matrix that we just got and apply the third elementary operation. So we're going to say row 1 is now row 1 plus 2 times row 2. So this is this itself plus 2 times this, which means it's 1 plus 2 times 21, which is 42 plus 1, 43. 2 times 3 is 6, 6 plus 3 is 9. 2 times 9 is 18, plus 2 is 20. So by applying that operation, you've ended up with this. So if you remember the first number that we used, so the first matrix, and you can just feel free to go back and look at it. With 3 sets of operations, you've ended up with a completely different matrix, right? Now, in this case, I just applied them randomly, so there's no real meaning to this. But when you're trying to solve certain matrix problems, you can apply these operations in a very planned manner to end up with a completely different matrix form that you need, for a certain purpose. So you can also see this when you're trying to solve, a collection of equations, which you solve by converting them into matrix form and then applying these operations to solve the system of equations. Okay. So now that you've understood these 3 elementary operations, please go ahead and try a quick test on TeachYaar.com to get some more practice and to make sure you've really understood these concepts. And I've dropped a screenshot of that test, some of the questions of that test here. So to take the test, you can scan the QR code on your mobile device, or you can go to this link, and we've dropped this link in the description and the comment section, so you can click on that and that will take you to the test. And it's a free test, so please feel free to try it out. And please subscribe to the TeachYaar YouTube channel to get notified as we add more content.